Hello everyone, welcome back to my channel. So as we discussed that today we are going to learn about typecasting in Java. We'll just have a quick recap that what we have studied till now. Okay, so yesterday we started with the primitive data types. So we discussed about all the 8 primitive data types like byte, just yes. So yes, so yesterday we discussed about the 8 primitive data type like byte, short, int, long, float, double, char and boolean, and so we saw the difference between each of them. Like whenever we want to store a fixed number, we can use byte, short, int and long, and we also saw the difference between all of them. Like the long was the largest among the 4 integer types, that is between byte, short, int and long, and the byte was the shortest among all. And while I need to store decimal values, I can use float and double. And also we have discussed that we need to use the tailing L when we want to store values that are beyond int range in the long, and even in the float I need to use tailing F. So I hope till now it's clear to everyone. And we also discussed about the char and boolean. So in char we can store only a single character, while in boolean we can store only true and false values. So anything other than true and false will give us an error if we try to store them in boolean. So now today, as I promised, that we'll be dealing with typecasting in Java. We'll first see what is typecasting, and then we'll see how many types of typecasting do we have. So let's get started with this. So first I'll tell you what is typecasting. Yes, so typecasting, with the name itself, it says that casting one's type to another. So if I ask you that you need to cast one's type to another, now your question may be that how can I do this task in Java? So in Java we know what are types. We have discovered 8 data types till now: byte, short, int and long, and after that we discovered float, double, char and boolean. So these are the 8 data type that we have discovered till now. Now we need to know that how can I cast this data type to this one, or this data type to this one, or something like that. So this is nothing but called as typecasting. So casting one type to another is called as typecasting. So if I want to cast my int type to long, I will be doing a typecast. So this is the meaning of the word typecasting. Now there are 2 ways of typecasting. First one is implicit typecasting, another one is explicit typecasting. So we'll see that what is the difference between this kind of typecasting, that what is the difference between implicit typecasting and explicit typecasting. Yes, so first we'll see the definition of typecasting. It says that assigning variable or literal of one type to the variable of another. So this is an example that I have a variable int, I have a variable of type long. So if I want to cast long's value to int, this is a kind of typecast because I am casting the long value to int value. And another example is I want to cast bytes value to int value. So now these are the examples of typecasting. We'll see how we can perform this. And one thing you need to know, that only numeric to numeric typecasting is possible. So the reason for this is, can I cast anything to boolean? Your answer will be no, because boolean can store only true or false. We have the data types that we have discovered till now, only boolean is the one that stores only 2 values, that is true and false. Anything other than true or false cannot get stored in boolean. So I cannot cast any int to boolean, or I cannot cast boolean to int as well. So only numeric to numeric typecasting is possible, in which we also have char. We'll see how we can cast char but for now we are just going with what is typecasting, then we'll move to what is implicit and what is explicit. So this point is clear that we cannot cast to boolean because casting takes place to in only numeric to numeric values. So as I have discussed that there are two kinds of typecasting. First one is implicit typecast, another one is explicit typecast. So we'll discover what is the difference between them and how can we perform the same. So the first one that we are going to study is implicit typecasting. So with the name itself we can say that implicit means without any efforts, we can say that. So if I want to do something implicitly, or implicit means we don't have to do something by ourselves. Okay, so in implicit typecasting, which is also referred to as widening conversion. First we'll see what is implicit typecasting, then we'll see how can I perform that. So implicit typecasting means we'll just relate it to our real world scenario. We are having a container and we have another container. So this is a smaller container and this is the bigger container. So obviously if I ask you that can I store the content of the smaller to the bigger one, what will your answer? You will say yes, I can easily store this over here, I can easily store the smaller container over here inside the bigger container, because the bigger container is having the capacity of storing the content of smaller one. So do I need any extra efforts? No, I don't need any extra efforts. So this is something called as implicit way. So in Java we can also do the same. If I am having a smaller data type like int, or I can say like byte, and if I want to store its content or I want to cast its value to int, so int is 4 byte, byte is 1 byte, so can I cast bytes value to int? Your answer will be yes. So this is nothing but implicit typecasting. Okay, so I hope this is clear to everyone. So if I am having a variable int x and int x and long L, so can I store any value that is given to x like 65 to L? Your answer will be yes, definitely, because long is a bigger container of 8 byte and int is a smaller container of 4 bytes. So I can easily store 4 in 8. So anything inside this container can get stored inside this container. So it is easy to store this kind of value. It is easy to cast from smaller to the bigger one. So the reason why it is being called as widening conversion is straightforward, that this container is smaller, this container is bigger. So I am storing the smaller content to the bigger content, which means I am widening my conversion, means I am doing a conversion from smaller end to the larger end. So I am widening. So that's the reason why it is referred to as widening conversion. And integer to floating point is implicit too. We'll see this point when we after a while, but first we'll perform this in Eclipse and we'll see whether it works well or not. So let's move to Eclipse and let's try some code. So let me declare the main method. Yes, so in the main method what I can do, int x is equals to 70 or 87 and long L is equals to, or I can just make this like this. So can I store L or can I store x in L? You will say yes, definitely, because x is a smaller container of 4 byte while L is a bigger container of 8 byte. So it is easier for us for storing x value inside the L. So if I try to run this, I get the value of L as 87. So this is very easy because L is a bigger container. I can easily store the content of the smaller container into the bigger one and it won't need any extra efforts. So that's the reason why it is called as implicit typecasting. Or let's try another example as well. So you know that float is smaller than double. So for float I need to give trailing f, and after that I can declare a variable double d is equals to f. So obviously the f can get stored inside the d. So if I try to print the value of d now, Yes, we get the output as the, see, now what happens is, as I said, double's precision is bigger than, see, for float it is exact because we have defined it exactly, but what happens behind the scene when I typecast this, we can say that there is a information loss like this. So what happens, it tries to convert it into the double format, and we have some kind of information loss because the double's precision is approximate 12 to 15 digits after the decimal, so it tries to match that. So, and also it is because of the encoding schemes in Java, so we don't have to worry about this, but we just need to be aware that there can happen these scenarios. Or if I give any values, so let's say double s is equals to 8, 8 is now interpreted as int, so can I store int to double? You will say yes, definitely, because double is very much bigger than a normal int. So if I do s now, what will happen? There are no decimals, so no information loss for now. And if I say 8 point, only 8, now what will happen behind the scene? It will read it as 8.0 because doubles and float always store the decimal values, so it will count it as 8.0. Now one more thing, if I give 8 like this, see, there is no such information loss. The reason for this is I am not typecasting any values to double, I am directly giving the fixed value to double. Over here I was giving this value to double. Sometime, see, now if I run this again, yes, so again the same thing happens because when I do typecasting from float to double, it tries to match the precision of the double values, that is of 12 to 15 digits. So that's the reason why we again get this kind of information loss while typecasting from float to double. And also if I give direct values to double, then there won't be any information loss. Or if I give 56 like this, there won't be any loss because 56 again is a direct number, there is no decimals. If I give 0 to it, let's try this one as well. Now again there is no issues like this, see, but as soon as I give any number over here after the decimal other than this, other than 0, then we'll get some information loss of some 0.000 point something. So yes, it's not a big deal for now, but yeah, that might cause some issue in the calculations. So I hope this is clear to everyone till now, that conversion from float to double is implicit. And someone is asking that please explain float f is equals to 56.87 f. So why is f is in the last? So what is this telling f? So yesterday in our previous session that I already discussed about that why do we need a tailing f. So if I don't write any tailing f over here, it will interpret this decimal, it will interpret this decimal as a double. So what will happen, it will give us an error that hey, there is a type mismatch that I cannot convert from double to float. So to tell the compiler, hey compiler, this is not a double value, it is a floating point value or it is a float value, you need to give the tailing f, or you can also give the capital letter f. Now one more thing, if you don't give any decimals after that, so there is no need of giving any f, because as I said, only decimals will get read as double value. So if this is not a decimal, this is read as int, and as I said, int is smaller than float, and we'll discuss this again. So yes, so this is the chart that we can follow. So let me explain this one. Okay, yes, so what happens, byte is the shortest, then comes short, then comes int, and then comes long. So this is clear that I can cast byte to short as well, byte to int as well, byte to long as well. I can cast short to int, short to long and into long. So this is implicit conversion for this integers, right? We have defined this as integer, the 4. Yes. Now what happens after this? Float and double. So obviously float is smaller than double, so I can cast float value to double. This is again clear. So this is floating point and this is integers that we have defined already. Now char, we'll discuss about this after a while, but for now we'll discuss about integer and floating point. So though long is of 8 byte and float is of 4 byte, conversion from long to float is implicit too. The reason for this, as you all know that float is 4 byte and long is 8 byte, there might be a doubt that how can I convert 8 byte to 4 byte, but as I said, it works on the basis of the range. So for long it was minus 2 power 63 to positive 2 power 63 minus 1, but for float it was something around minus 3.4 into 10 to the power 38, I guess. We can see that. If you want to see the range, we can refer to the chart that we have discussed in our previous session. So for float, this range was the minimum. So is this range bigger than this range? You will say yes, definitely. So I can store long values in the float as well, though in the memory it will consume 4 bytes only, but actually the range for float is bigger than the long one. So this is only the memory allocation. The memory will get allocated for long as 8 byte, for float as 4 byte, but the range for float is bigger than the long. So if it is bigger than the long, which means I can cast byte as well, I can cast short, I can cast int as well to float, and if I can cast it to float, then I can also cast it to double. So I can cast all these 4 to the float and double, which means conversion from integer to floating point is implicit. I hope this point is clear to everyone. So we have discussed the last point. Now we'll see, is the conversion from char to int implicit or not. So for char it is only 2 bytes and for int it is 4 bytes. So it is obvious that I can cast it to int, I can cast it to long, I can cast it to float, I can cast it to double. So I hope this chart means you are able to understand this chart and this flow, that how implicit typecasting works. So I can cast byte to short, by short to int, and into long, and long to double, sorry, float, and float to double. So this is the way, and though byte is of 2 bytes, I can store or I can assign its value to any of this: int, long, float, and double. Yes, so this is clear to all. We'll again check that whether I can cast into float or not, into long or not, and long to float or not, and float to double or not. So let's discuss this. Yes, so now if I have a variable, now see over here x value is getting into the else value, so L is getting the value assigned that is equal to x. So now over here our L is equals to 87. Yes, now can I cast this 87 to float? Previously we knew that long is 8 byte, float is 4 byte, but we also know that yes, float can store the values from the long. So can I store L over here? You will say yes, definitely, and I don't need any extra efforts. So this is a type of implicit typecasting. So now this F has the value 87.0, double has the value 87.0, and this is as it is. So let's run this. Yes, so can you see this? First the value of long 87, then the value of float and double comes out to be 87.0, and then for this as it is as it is. So this proves that conversion from integer values, because if I can cast long to float, which means I can cast any of the integer like byte, short and int as well. So this proves that conversion from integer to floating point is implicit too. Now we need to understand that we need to prove that whether conversion from char to int is implicit or not. So if I define int I is equals to c, so is it implicit? Yes, because there are no errors for now. Now if I try to print the value of I, what will happen? Let's see, we'll get 97. Yes. Now I'll again explain this, though we have discussed this yesterday, but let's discuss this again. So now char c is equals to a, c pointing to a 2-byte memory space. In the memory, a is getting stored over here. Now as soon as I declare I, okay, I is pointing to a memory space of 4-byte in the memory, in which I need to store the value that is equivalent to char c. So where c is pointing? C is pointing to this memory location. This memory location has a, can I store a over here? Your answer will be no, I cannot. So now there is a need of converting this a to int value. So it will fetch the ASCII chart, and in the ASCII chart for a it is 97. So it will store 97 over here. So we'll get 97. That's what we have got over here. I hope this is clear to everyone. And now let's convert. Instead of int, I'll use double over here. Yes. So if I do this, let's see what do we get. Yes, over here we again get 97.0. so again there is the same process, but yes, though it is a double, it will store the 97 as 97.0. again we can have a recap that this points to a, I points to a 8-byte memory location. 8-byte memory location needs to store this a. This cannot be get stored directly, so it need to, there is a need to convert this into a number. Can I store 97 over here? Yes, but it will be read as 97.0. so in the memory it is stored as 97.0, because both double and float always store numbers in decimals. Yes, so someone is asking that only numeric to numeric typecasting is possible. So typecasting for char, it use ASCII. Yes, definitely, because what happens, though char holds a character, we can get a numeric value for this particular character, correct? So I can fetch the value for a, for b, for other character as well. For capital letter A we get 65. So these are nothing but a numeric value. I am converting this to this, but what happens behind this in, it is getting converted from a numeric value, that is 97 to 97.0, or from char to int or double, whichever we choose over here. But yes, behind this in, it is converting the numeric values. So I hope this is clear to everyone. Yes. So someone is asking that what is the use of typecasting. So we will see what is the use of typecasting when we discussed methods, and also we'll see after when we proceed with operators as well and other topics as well. So let's proceed. So now the another type of typecasting is explicit typecasting. So explicit typecasting, you have already guessed that explicit means we need some extra work to perform this task, or we need something to do it by ourselves. So implicit didn't need any extra efforts, it was happening by itself. So it was a widening conversion, because we were storing smaller values to the larger one. But explicit is the complete opposite of implicit. So in explicit we have conversion of larger values or larger data type to the smaller one. So now I'll ask you a question, that there is a bigger box, can I store the content of it in a smaller box? You will say no. Then I'll say you have to do it. Then you will do it forcefully. You will take out all the content of it and you will try to store it forcefully inside this, and somehow you can be able to manage if the content is small. Yes, so the example of this is conversion of long to int, because long is 8 byte, int is 4 byte. So can I store it easily? No, we need some extra efforts. We need some force to perform the task. Can I store double value into the float? Again, we need some extra efforts. So what extra efforts do we need to perform this thing in Java? So we need to write something before performing these values or before performing this action. So if I want to, okay, let me declare a variable double d is equals to 45.6. This is a double variable. I declare a variable float f equals to, now I need to store d value to f. Now it cannot be done because it will give us an error. Hey, there is a type mismatch, I cannot convert from double to float. So now you will say, hey compiler, you have to forcefully do it. So what you can do is, inside the parenthesis you can give the type compatible to this. See, now one thing that you have seen, that you usually write only the same values like this. Float is, if float is over there, then you will write float over here, but it is not always necessary to use only float and float. Over here you can give any type that is compatible to float. Now what do I mean by compatible? Can I store int to float? You will say yes, definitely. So I can use int over here as well, but I am doing what behind the scene? I am forcing my compiler to convert this value into int first and then convert it to float first. So I hope this is clear to everyone. Yes, we will see that what is truncation, but first we need to see the concept first. Okay Atul? Yes. So now we have discussed that how we can perform the explicit. Let's do it in a practical way and then we'll see what is truncation or what is information loss. So this implicit, I'll just comment this out. Okay, so command slash, yes. Now I'll define two variables that we have discussed, like double d is equals to 56.81. now float f is equals to d. Now if I do this, will I get any error? Yes, we will, because it will give us an error that hey, there is a type mismatch, cannot convert from double to int. Now I'll tell the compiler, hey compiler, you have to forcefully do it. I don't know how you will, but you have to do it. Yes, so I have given this float to explicitly typecast it to float first and then assign to float. So if I say system.out.println and if I say f, see, I get the value as 56.81. okay, so which is the correct value? Now if I, okay, first I'll just perform this. If I do it to int, is int compatible to float? Yes, because there is implicit typecasting. So wherever implicit typecasting takes place means it is compatible. Yes, so now if I run this, we get 56.0. So now why there is an information loss over here, or why there is, why 81, where the 81 is? So now I'll tell you the reason behind this. What I am trying to do over here is d is having 56.81. I need to first forcefully convert it to int value. So I converted it to 56 because int cannot hold any decimals, so it will only truncate. See, it won't give any approximate values like 57, though it is, even if it is 56.999, then too it will give 56. It will always give the flooring values, the floor values. So over here it truncated to 0.81. Okay, now if I try to store this in float, what will happen? 56 will be stored as 56.0. So that's the reason why we have 56.0 in the console. Yes. So after this, what we can do is, if I write float over here, what will happen? If I write float over there, 56.81 will be forcefully converted to float, that is 56.81, and then this will be stored in the memory address of float. Now whenever I fetch this f is pointing to this, and we get the output as 56.81. so we can define explicitly over here that, hey, I need to convert it to float. Yes. So I hope this is clear to everyone. So if I make it float again, and you can practice other data types as well. So for example, instead of doing this, if I say double d is equals to 90.9999898, this is a double value. If I try to store it in a int value, what will happen? We'll get an error. So to solve this error, I'll say you need to forcefully convert it to int. Okay, so now what will be the output? You would have probably guessed that it will be 90, because it will truncate to the floor value. Yes, so now we can again understand this, why it is truncating. So let's see what is information loss. Yes, but before that we'll see how we can means what is the chart for explicit typecasting. So for explicit typecasting we have this chart. Yes, so this chart says that double to float is explicit. That is obvious because double is 8, float is 4 byte. So conversion from float to double to float is explicit, and you already knew that long, int, short and byte is always smaller than float and double. So any conversion from this will be always explicit. So if I want to convert any values like this, I need to give the I need to provide some extra efforts inside the parenthesis. So this is something that we do explicitly. And now this is an interesting thing, that conversion from byte to any of them needs a explicit conversion. I'll explain you how. So if I convert from short, or if I convert from byte, you know byte is the shortest among them or smallest among them. So if I say byte 65, you know the value for 65 in the ASCII. So 65 stands for capital letter A. Now if I do char C is equals to V, will it work? You will say yes. Now let's try this. Will it really work or not? So if I move to Eclipse, if I say byte B is equals to 65, char C is equals to B, do we get any error? Yes, we do get, correct. So this error says that cannot convert from byte to char. Now you may wonder that why, because byte is the shortest and char is 2 byte and byte is 1 byte. How come I cannot store the bytes value to char? Now the reason behind this, as I have discussed with you in a previous session, that for char, for characters, the range starts from 0. Am I correct? The range for char always starts from 0 to 2 power 15 minus 1. But for byte, it starts from minus 128. For short, it starts from minus 215. Okay, so now though the positive range of byte and short is similar, or char can store the positive range of byte and short, but char cannot store this negative range for this particular types. So it always starts from 0. Can it store minus 1? No, we cannot store minus 1 to char, because char range starts from 0. So that's the reason why if I want to store this, it cannot be done easily. I need to tell the compiler to perform the task forcefully. So let's try that one as well. So we'll say here system.out.println C. What is the value for this? It comes out to be A. If I do this, see, we don't get any characters like this because negative value cannot get stored in C, but though I am forcing it to do, we won't get anything like that. Okay, sorry for this. I'll just make it as int. Yes, see, it is not the actual value that we get in the ASCII chart. Yes, because negative values get interpreted something differently and we don't have to worry about this because our main focus over here is that conversion from byte to short, byte, short and int to char is always explicitly. Though byte is the shortest among them, then too will have to perform the explicit typecasting. Yes, so if the value is over, it will work. Yes, so we'll discuss about the information loss, don't worry about that. And class 12 is asking that float f is equals to int d. What is happening? Can you please repeat again? I didn't get what's happening. Okay, sure, I'll definitely repeat it. So let me declare these variables again that we have discussed. So your question is, yes, so I'll declare first float. Okay, double d is equals to 98 point some values like this. Yes, now I need to store it in float. Float f is equals to d. Can I do it? No, I cannot do it easily, so I need to give some explicit typecasting. Can I cast it to float? Yes, because I need to convert this value to float, and if this value gets converted to float, will it be easier for float to store float value? You will say yes, definitely. Correct. So that's the reason why we need to convert it to a compatible type. So that's the reason why I am writing float over here. So if I say f over here, it will work fine, no issues. And though I said that the precision for float is only for 4 to 5 values, so that's the reason why we don't get the correct number. Or if I use this, yes, so we get the actual output. Now as I said that over here I need to give a type that is compatible to float. So can I convert int to float easily? You will say yes, because int is smaller than float. Now what will happen behind the scene? Over here what happens behind the scene is, as soon as I convert this d, what I am trying to do, 98.90876, I am trying to convert it to int first. I want to convert this value to int first. So what will be the int representation for this? It will be 98, and then I need to convert it to float. So for float it will be 98.0. So that's the reason why we get output here as 98.0. So let's see this. See, we get value as 98.0 that we already discussed. So the reason behind this is we are converting it to int. Even if I convert it to byte, what will happen? We'll get the same output, because it will convert this type to byte, and byte cannot store decimal, so it will always truncate to it to 98, and 98 will get assigned to float and it will be read as 98.0. So is it clear to all? Yes, after int it again gets typecast to float. That is the implicit typecasting that is happening behind the scenes. It will truncate the decimal and take the 56. It will, yes. Okay, so now we'll discuss what is information loss. So over here I am having so over here I'm converting double to float, float to long, long to int to short, and short to byte. Now what we discussed, there is a bigger container, I need to store the content of it in a smaller container. But till now, have you seen our container? the content of our container was 98.90, and can I store 98 or 100 in int? You will say yes, definitely. So now what if my container is having a big data? So now let's relate it with a real life, that if our bigger container is having capacity of storing 9 balls to it, and our smaller container is having only capacity of storing 4 balls in it. So if I ask you, hey, you have to store all the balls of this container into this, will it be possible for you? You will try to forcefully insert it, but what will happen at the end? Only 4 will get inserted, or we can say that other will get spilled out. So other will be spilled out. So this is something called as information loss. So if we try to store the value that is bigger than the smaller data types range, then there will be an information loss. Can you please show the flowchart of the implicit? Want to take the screenshot? Yeah, sure, I'll just show it again for implicit, but first we'll discuss this, what is information loss. So if I try to store larger data in a smaller one, what will happen? It is obvious that we will have a information loss. But one thing you need to point is, like over here in a real life, what happens? 5 over here, 9 balls, I can store 4 and 5 will get spilled out. So you are obvious that 4 will always get stored. But what happens in the programming? Not 4 will get stored, there will be some random numbers like -1, 1 or something, any random numbers. So this is the information loss. So please be aware about that whenever you are storing or whenever you are performing the explicit typecasting, you make sure that you don't have information loss, because if you have, there will be a big issue when you are calculating the task. So let's try this. So over here, okay, I'll just do it conversion to int, or let's take a byte, okay, and I'm converting it to byte. Now bytes range, you all know that it is 127. So if I give 127, will it work? You will say yes, definitely. If I give 128, let's see what output do we get. See, it gives -128, but don't think that this -128 is because I'm giving 128 and it is just changing the sign. Let's give 129, it will give 127. See, there are random numbers like this. Okay, if I give some bigger values like this, see, can you see the output? So don't rely that it will have some values around 127. No, it won't be. If you try to give any bigger values, then it will be difficult, or it will be impossible for this data type to store that particular value, and there will be an information loss. So this is something called as information loss. So when we were dealing with float, we have already seen a information loss. So when I was writing some values like this, see over here, this is a big digit. Can I convert it to float? You will say yes, you can, but see the precision. Can you see the precision? There is an information loss. The precision changes. See, it takes the approx value of this. So instead of this, it will take 4. So I hope this is clear to all. Now if I do this, see, again it is truncating, or I can say that this value gets spilled out, or this gets out of the memory. So that's the reason why you have to be aware that yes, there can be an information loss while performing the explicit typecasting. So yes, so this is explicit typecasting. Someone wanted to see the screenshot, the chart for this. So I hope you are able to see this. Yes, so this is the chart for implicit one. The conversion from integer or character to the floating point is implicit, and the conversion from the reverse order is explicit. And in explicit, we also saw that why conversion from byte to char is explicit. So for explicit, we need to provide some extra efforts. We need to tell the compiler, hey compiler, you have to perform this task forcefully. Okay, if you cannot do it by implicitly, you have to do it explicitly. Okay, now as we discussed, the values might go outside the range of that particular data type, and at that time, at that moment of time, we'll have the information loss. And if I store double values to int, there will always be a truncation, and we already knew that because int cannot store decimal. So even if this is 99999, then too it will be read as 167. So this is something called as truncation. Truncation means coming to a value that is lower than the actual value but not the higher values. Okay, so over here this is truncating to 167, though we can approximate it to 168, but what happens in Java, it truncates, which means it will always give us the floor value. Yeah, so yes, so we have discussed about information loss, and in implicit as well we have seen the information loss while we were converting from float to double. Yes, so I hope this typecasting session is clear to everyone. We have seen the typecasting, and again someone is asking that what is the use of typecasting. We'll see that when we proceed to the methods and other topics, so don't worry about this. Yes, and conversion of the conversion of means the implicit typecasting is too usual. Like you will see it very often, like there is a variable int s is equals to 56. Okay, now later you want to store it in a bigger variable, so long L, you can store it easily, and this won't affect you any issue, and this won't create any issue. So it is implicit because long is bigger than int. So it is usually, you can often see this kind of conversion, but explicit is not that often. But yes, then too we need to be aware about that explicit typecasting, and yes, it is being used in Java and even in some programs. And when we move to operators, we'll have a quick recap that how we can use this explicit typecasting when we are performing divisions or any other calculation. So don't worry about this, we'll see the use of typecasting as well, because we haven't completed much topics yet, so I cannot go into that topics for now because it will create a very big confusion. Like if I introduce methods over here, then it will be a big confusion. So that's the reason why we have just discovered what is typecasting, what is the kinds of typecasting, and how we can achieve typecasting in Java, and what are the rules and what are the limitations. So yes, so do you have any doubts? You can just post in the live chat. Okay, so today's session was quite short than our previous session, but yes, we have completed the topic completely. So now I believe that you won't face any difficulties while dealing with typecasting, and even in the interviews you can crack the typecasting scenarios. Yes, so now I'll just, can we do weekly quiz or learning on that week? It will help us. Okay, so I'll try to give you some problems, but for now, like with this data types and typecasting, there are not much problem. Like you can do it by yourself also, because this is a very small topics like that. But when we move to loops, we'll definitely solve it in the live sessions as well, so don't worry about that. We'll also see different kinds of scenarios and approaches as well. So yes, so I hope it is clear to all, and tomorrow we'll start with arrays, because we are now dealing with the data type. We need to store some data in a variable. So we have discussed 8 primitive data types like int and all. Then now we'll see arrays, and in arrays we are going to see all the 3 kinds of arrays: the single dimensional and 2D array, 3D array, that is multi-dimensional arrays. So tomorrow's topic is arrays. Sir, how to run Java? What do you mean by how to run Java? If you are using any IDE like Eclipse, you can just right click on the program and run as Java application. Or if you are using any if you are creating any files, so what you can do is in the terminal or in the command prompt, you can just go to that particular file location and you can use the javac command to compile the particular file. So I can say javac the file name, let's say the file name is hello world.java, and if I run this it will compile fine, and after that I can say java and the file name. So this will run our program. So I hope your doubt is clear. Yes. So see you all tomorrow at the same time, that is 7:30 p.m. IST, and if you have any doubts you can just comment it in the comment section. So thank you all for joining today's session. We'll catch up tomorrow at the same time.